Hello friends. This video is brought to you by mywayteaching.com.
We know that there is one and only one line which can pass through two given points. A natural question arises, how many points are sufficient to determine a circle? So let us take a point P. Then how many circles can pass through this point? We can see that we may draw as many circles that we like through this point P. Now suppose we take 2 points P and Q and see how many circles can be drawn. Again, there can be infinitely many circles that can be drawn through 2 points. Now let us take 3 non-collinear points P, Q and R. That means they should not lie on the same line. And try to draw the circles passing through all the 3 points. If you try to draw it using a compass, it won't be easy. So we need a technique. Let us join PQ and PR. Now draw perpendicular bisector of PQ and PR. We have already learned in previous classes how to draw perpendicular bisector of a line. We have drawn perpendicular bisector of PQ. Similarly, let's do it for PR. And let the point of intersection of the perpendicular bisectors be O. Since O lies on the perpendicular bisector of PQ, so OP is equal to OQ. Similarly, O also lies on the perpendicular bisector of PR, so OP equal to OR. That means we have OP equal to OQ equal to OR. So we can take OP as the radius and draw a circle with O as center. We finally get a circle which passes through point P, Q and R. Now you know that two lines can intersect at only one point. The two perpendicular bisectors bisected at point O. So there can be a unique radius for a circle which has center O, and hence there can be only one circle which passes through 3 given points. And this brings us to the conclusion that there is a unique circle which can pass through 3 given points. Now we are in a position to state theorem 5, according to which there is one and only one circle passing through 3 given non-collinear points. For the proof, let us take 3 points A, B and C, and they should not lie on the same line, or in other words, they should not be collinear. Now draw perpendicular bisectors of AB and BC. Let these perpendicular bisectors meet at the point O. Now, as we know that every point on the perpendicular bisector of a line is equidistant from its endpoints, so all the points on the perpendicular bisector of AB will be equidistant, and since O lies on the perpendicular bisector of line AB, so OA is equal to OB. And for the same reason, since O lies on the perpendicular bisector of the line segment CB, so OC equal to OP. Let us mark them 1 and 2. From 1 and 2 we have OA equal to OB equal to OC. This means that the points A, B and C are at equal distance from the point O. So if we draw a circle with center O and radius OA, it will also pass through points B and C. This shows that there is a circle passing through 3 points A, B and C. This shows that there is a circle passing through 3 points A, B and C. We know that two lines can intersect only at one point. So the two perpendicular bisectors can intersect only one point, which will be equidistant from point A, B and C. So we can say that we can have a unique circle which will pass through points A, B and C. Hence we have proved the theorem. There is one and only one circle passing through 3 given non-collinear points. Theorem 5 also gives us the information that if ABC is a triangle, then since the vertices A, B and C are 3 non-collinear points, so by theorem 5 there can be only one circle that can pass through points A, B and C. This circle is called circumcircle of the triangle ABC. The center of this circle is called circumcenter, and the radius of the circle will be called the circumradius. Let us read the question. Given an arc of a circle, complete the circle. We start with assuming let PQ be an arc given to us. We have to complete the circle, which means that we have to find its center and radius. So let us take a point R on the arc and join PR and RQ. Now it remains to construct perpendicular bisectors of PR and RQ, and where they meet will be the center of the required circle. Now we have a point O, which is the center of our required circle, and it is equidistant from OP, from point R and point Q. Now with OP as radius and O as center, we can complete the circle. So we get the required circle in this manner when we are given one arc of the circle.